Today, we are cracking the code on a metric called OEE, or Overall Equipment Effectiveness. It's just a single number, but it can reveal this incredible hidden story of what's happening inside a factory, and we're going to break down exactly how it does that.
So let me ask you this. What if there was just one number that could tell you what's really going on out there on the factory floor? I mean, a number that doesn't just give you a grade, but actually helps you diagnose problems and points you right to the solution. Well, that number is OEE. And to really get our heads around it, we're going to follow this fantastic numerical example from the work of Mohammed Al-Jaloni. And what I love about his approach is that it's all about learning by doing. We're not going to get bogged down in dry definitions. We're just going to do a hands-on investigation. So here's our game plan. First, we'll get a quick definition of OEE. Then, we're going to dive into two totally different production jobs. We'll compare them, uncover the real story behind the numbers, and then we'll wrap up by talking about what OEE is really for and, how to use it wisely. Okay, so the star of our show is this machine, a 300-ton plastic injection machine. Think of it as a total workhorse running 24/7. And on this one particular day, it has to complete two very different jobs. And that, right there, is where our story really begins. Now, some people will show you this shortcut formula for OEE. And look, it's pretty straightforward. You just take your good output and divide it by your theoretical maximum. And yet, mathematically, it'll spit out the right final answer.
But here's the thing. This is a trap, and it's a really critical point. Using that shortcut completely hides the why behind the number. You end up with a grade, like an A or a C-, but you lose the entire diagnostic power of the tool. It basically makes it useless for actually improving anything.
So the proper way to do it is to go on a hunt for losses in three specific categories. First, we're going to look for any lost time. That gives us our availability. Then, we hunt down any lost speed. That's our performance. And finally, we have to account for any bad parts, and that, of course, is quality.
All right, let's see this in action with our very first job, an 8-hour production run, making nylon gears.
So, to find our availability, we start with the plan. The machine was scheduled to run for a full 8 hours. But you know how it is, a breakdown happened. That caused about a half hour of downtime. So that means it only actually ran for 7.5 hours. Now, we just do the math. We divide the actual runtime by the planned time. That's 7.5 divided by 8, and we get an availability score of 93.8%. Hey, not bad at all. Okay, next up is performance, and this one is all about speed. In those 7.5 hours, theoretically, the machine could have cranked out 12,000 parts. In reality, it made 11,600. So it was running just a little bit slower than its absolute top speed.
So we divide the actual output by the theoretical, and that gives us a performance score of 96.7%. I mean, that's a really solid result.
And finally, we've got to look at quality. Of all the parts it made, all 11,600 of them, it turns out 500 had defects and had to be scrapped. That leaves us with 11,100 good, shippable parts. So dividing our good parts by the total parts made gives us our quality score 94.8%. And now for the grand finale, the final OEE score. We multiply our three components together, availability times performance times quality. And that gives us a final score for this first job of 86%. Now to put that in perspective, 85% is often considered world-class. So this looks fantastic, right? Well, as we're about to see, that is only half the story. Okay, now let's look at the second job, a 14-hour run for some polypropylene caps. I want you to pay close attention to two little details here. First, this job requires a 2-hour setup to change the mold. And second, it's designed to run much, much faster. These details are going to become very important. So the plan for this job was 14 hours. But right out of the gate, we lost 2 full hours to that mold changeover. And on top of that, there was another hour of breakdown. That's 3 total hours of downtime, leaving us with only 11 hours of actual runtime. And you can probably guess what that does to our score. We divide 11 by 14 and, our availability just plummets to 78.6%. That is a huge drop. But here's what's so wild. During the time the machine was running, it did great. I mean, look at this. Performance clocked in at 95.1%, nearly identical to the first job. And the quality of the parts? Outstanding. A stellar 98.5%, even better than before.
But, and this is a huge but, when you multiply that great performance and that great quality by that terrible availability score, the final OEE just gets crushed. It drops all the way down to 73.6%.
So this is the big question. Why? I mean, it's the same machine on the very same day. What on earth happened to cause such a massive drop in effectiveness?
I mean, just look at them side by side. We went from a world-class 86% all the way down to a pretty mediocre 73.6%. The answer has to be hidden in the details somewhere.
And this right here, this is the genius of OEE. It's not just a grade, it is a diagnostic tool. Take a look at this chart. Performance was stable. Quality actually got a little better. The problem is just staring us right in the face.
The culprit, the one factor that completely tanked the entire score, was availability. It just fell off a cliff, going from nearly 94% down to under 79%. And we know exactly why, that 2-hour changeover.
This brings us to probably the most important point of all. What is OEE actually for? And, just as important, what is it not for?
Okay, it's really crucial not to confuse OOE with another metric called utilization. See, OOE only cares about how well you performed during the time you were scheduled to run. Utilization asks a totally different question. Out of all 24 hours in a day, how many of them were you even scheduled to work in the first place? They're measuring two very different things. At the end of the day, OEE isn't just some number you stick in a report. Think of it like a special lens that's designed to make all those invisible losses, time, speed, quality, perfectly visible. Its real purpose is to force the most important question of all. Okay, now that you can see the problem, what are you going to do to fix it? All right, finally, let's just take a step back and get a practical perspective on OEE. It is a really powerful tool, for sure, but like any metric, it's not without its limits or its critics. So before we close, let me mention one important point. Sometimes you'll hear OEE get criticized by statisticians because it multiplies these three very different components together. They say it's kind of like multiplying a person's height, weight, and blood pressure to get one single number for health. You know, they're different kinds of measures, so mashing them together can sometimes hide important details. And you know what? That criticism is totally understandable. It makes sense. But in the real world, in practice, there is still so much value in OEE. So why is that?
Well, it's because OEE is not supposed to replace detailed analysis. It's not supposed to be the only metric we use. Think of it as a practical, high-level indicator. Its job is to give us one overall view of how we're doing on time losses, speed losses, and quality losses. And most importantly, it shows us where we need to go look deeper.
So if OEE shows us there's a problem, that's our cue to go deeper. If quality is the issue, okay, we break out the control charts and other statistical tools. If setup losses are high, like in our case study, we get to work on changeover reduction using tools like SMED. The point is, OEE is the starting line, not the finish line. So yeah, OEE has its limitations, but there's absolutely no harm in using it, as long as we use it in the right way, as a practical tool for improvement, not as the one and only measure of performance. It just helps you ask the right questions.